This video is still looking at 8.6 day 3, restricted domain solution and complete solution. We're looking at number 3 and 4. Number 3 is a little bit different because if you look at the argument, not only is it not just x, but it's actually pi x, which is going to explain why our restricted domain looks differently as well. So, like always, we need to work with that equation first. So we need to get the tangent by itself. So I have tangent of pi x, and I am subtracting root 3 from both sides and then dividing by root 3, which is going to simplify to just 1. So we need to be thinking, where on the unit circle does tangent equal 1? And that's 2 different places. However, they are both diagonally across from each other. So we only need to worry about that pi over 4, and we're just going to add pi k. So take the argument, which is pi x, and that equals pi over 4 plus pi k. Now we're going to have to divide everything by pi so that x is alone, which is going to make this x equals 1/4 plus 1k. So this is your restricted domains, your complete solution. That's your complete solution. Now let's look at the restricted domain solution. So just like the video from yesterday, I'm going to take my domain and I'm just going to rewrite it so that it has a common denominator of 4 because I'm dealing with a 1/4 in my solution. So this is going to be 0 to 12 over 4 instead. So what we're doing is we're taking the solution of 1/4 and we're adding 1 every single time, which is just 4 over 4. So adding 1, I get 5 over 4. Adding 1 more, I get 9 over 4. Adding 1 again, I get 13 over 4. And now I can already tell that I'm out of the domain. So our restricted domain solution is 1/4, 5/4, and 9/4. Okay, number 4, the argument is just a 3x, so this should be similar to what we did in the first video. We need to get cotangent by itself. So the first thing I'm doing is subtracting 4 from both sides and then dividing by 3. And then this is cotangent, so we need to use the reciprocal function, which is tangent, and we need to take the reciprocal. And if I rationalize, this will become root 3. So we need to be thinking, where is tangent equal to root 3 on the unit circle? And it is 2 values, but they are directly across from each other. So we're just going to worry about that pi over 3. And we're going to take the argument, 3x, and it will equal pi over 3 plus pi k. Remember, plus pi k because the values on the unit circle are directly diagonally across from each other. So we need to divide everything by 3 in order to get x by itself. So this is pi over 9 plus pi over 3k. And this is your complete solution. Okay, I reworked my notes a little bit. You still see the complete solution on the screen, and now we're going to work on the restricted domain solution. So again, you can use your calculator for this, but I'm just going to show it in fraction form. So I'm going to rewrite my domain with a denominator of 9 so that it matches with my solution. So this is going to be 0 to 9 pi over 9. And I'm going to be adding pi over 3, which would be equivalent to 3 pi over 9 as I'm adding that to each solution. So we start with the pi over 9. That's in the domain. And I'm adding 3 pi over 9, which will get 4 pi over 9. And I'm going to keep adding 3 pi over 9, which is equivalent to the pi over 3, until I'm no longer in the domain. So it looks like, yep, there's a 10 pi over 9, so now I am out. So my restricted domain solution is pi over 9, 4 pi over 9, and 7 pi over 9.